I don't know why she didn't just come in and hand it to you. That was weird. But whatever. You know. No big deal. Okay. Hi, everybody. How are we doing? That's good. Today, let's start by taking questions from the previous assignment. So I think last time you guys worked on homework 4.1. If there's any questions from that, I'd be happy to take those here to start class. If anybody has anything. Should have been relatively straightforward. It was pretty easy in general, and most of the concepts I think there were largely review aside from some of the vocab, but the vocab is just vocab. It's not that bad. Okay, well, if you change your mind, you can always talk to me later, and I'd be happy to look at any other things that you might have questions about. Kind of move forward, okay? So last time, we had been working on simplifying quadratics, and we had kind of talked about these three different forms that we represent quadratics in: intercept form, standard form, and vertex form. So intercept form was this, standard form was this, and vertex form looked like this. Right, just as a refresher. We said to move from intercept form to standard form, we FOILed. To move from standard form to vertex form, we did this completing the square. From standard form to intercept form, we factored. And from vertex form to standard form, we said we expand. So I think at the very end of last time we had talked about factoring, but I'd like to do a little bit more practice on that today to start, and then we'll talk about how to do this completing the square task after we've done that. Okay, so that's the kind of the agenda here for today. Cool. So it's a little bit of a light day because my other section of this class was on the day that I was gone, so trying to get everybody back on sequence. You guys got a little bit ahead since we were there the other day, and I was gone for them the other day, so we're just kind of getting everybody synced back up. So we'll finish a little bit early today and give you some time to work on this assignment, but that's cool, right? Nobody's going to object to that. Okay, so factoring. I'm just going to do a few examples here today. As soon as I find my sheet I wrote my examples down on. There we go. And we'll do some of these, and then to kind of refresh our memory with this process. And then we'll talk about how to do completing the square and do a little bit of practice there. And then we'll combine some of these skills together. Okay? Great. So let's say we have the quadratic 12x squared plus 16x minus 35. So remember, to start, what we'd want to do is find the two numbers that multiply to give us times 35, which is negative 420, and then add to give us 16. Now at first glance, I don't see what those two numbers are. Do you guys? I don't either. So let's kind of make ourselves a little list, and we'll just kind of check this by exhaustion. So we'll just write down our factors that multiply to give us negative 420. I'll generate those. You guys will check to see if they add to give me 16. If you see a pair that works, just holler out at me, but I'm just going to generate these kind of brute force wise so that we don't miss any. So far, nothing good, right? Eight doesn't go in. 9 doesn't go in. $11 doesn't go in. $13 doesn't go in. 14. That's the pair that we needed, right? So, do you need to write all this stuff down when we do this? Goodness, no, right? I'm just writing it down so you can kind of see what I'm doing in terms of finding this. So if I don't see the factors right away, the two numbers that work, I'm just going to brute force it rather than do any guess and checking. So the advantage of the brute force is you're not going to miss the factor. Maybe it takes longer in an individual case, but I think overall it's going to be faster than like just guessing, right? Because you'll know that if you've guessed them all, because does this work every single time? No, right? There's not always going to be two numbers that satisfy this. So that's the advantage of brute forcing it through systematically, is you know when you're done that you've checked them all, versus if you're just guessing checking, you can go for a long time and be like, I don't know, did I check them all? Right? So anyways, so we 14 and positive 30. So we use those two numbers then to rewrite that 16x as negative 14x plus 30x. And then make two groups. When we do that, we make sure that there's a plus sign in between the two groups. So if you had written them in the opposite order, done positive 30 and negative 14, you'd have just need to make sure it's plus a negative 14 rather than subtracting 14, because you need to have a plus sign in between the two groups. But that's not a big deal, right? You can remember to write plus a negative instead of subtraction there. From the first group, my greatest common factor is 2x, right? So that's going to give me 6x minus 7. From the second group, my greatest common factor is 5. That'll give me 6, 7. That part in the parentheses should always be the same if you're doing this correctly. If they are different, it means that you've either chosen the wrong two numbers or you've done some little factoring thing incorrectly. So here, what do I do next? I factor out the 6x minus 7, leaving me with just the 2x plus 5. And that's my final answer. Are you okay with what we did there? We still kind of unsure about that last step that I make on why that works. So imagine I have this. 2x times a plus 5 times a. I can factor the a out to look like this, right? Well, what if a is just equal to 6x minus 7? Isn't that exactly what we did on the other side? That's it. That's all we're doing. Just the greatest common factor. But instead of it being a single number or a monomial, it's a polynomial that is the greatest common factor. But that's okay. Does that feel any better there? Or easier to see what's going on? All right? This is just our a. Ooh. Woo. Let's do another, huh? Let's say we have 15x squared plus 2x minus 1. We're going to start by finding our two numbers that multiply to give us what? 15 times negative 1, or negative 15. And add to give us 2. Right? Again, that's the a coefficient times the c coefficient, and then the b coefficient. Right? What are those two numbers? This one you should be able to do in your head without having to. 5 and negative 3, very good. Once we have that, we can rewrite the 2x as 5x minus 3x, but instead of writing minus 3x, I wrote plus a negative, because I need to have a plus sign in between those two groups that I make there. You get what I mean now about making it plus a negative instead of subtraction? So my greatest common factor in the first group is 5x. That leaves me with 3x plus 1. Remember, when we're pulling out those greatest common factors, we're doing division. So when I take out the 5x from 5x, I'm not getting 0. I'm getting 1. Right? Because it's a division action, not a subtraction action. Everybody's okay with that? Easy to make that mistake, so I'm just kind of reminding you guys. You guys knew it, but sometimes it's easy to forget that, overlook it, or get confused by it. If I look at the second group, my greatest common factor is, I would do negative 1. Why would I want to do negative 1 instead of positive 1? Yeah, we need these two guys to be the same, right? So if we took a positive 1, they would not be the same factors and we couldn't continue. If we take a negative 1, though, they will be the same factors and we're fine. Okay, then what can we take off? The 3x plus 1. What does that leave us? 5x minus 1. Oh, What do you guys think on this? Is it getting clearer? One more, and then we'll move on to completing the squares. Okay, seems fine with me too. Again, this is I think a pretty important skill, so I don't want to, shortcut through this, and we will spend some time in class doing like some really focused practice on this, where we just give you some, some timed practice and go, but we're going to do, come up with some shortcuts to deal with this process first before I start giving you guys some timed practice. Okay. So we'll start by finding the two numbers that multiply to give us negative 480, right? That's 12 times negative 40. And add to give us 17. Does anybody see the two numbers right offhand? Okay. If you don't, what do? We start by making our list. And again, no harm in not seeing them right away. It's well, it's a pretty big number, so I don't blame you guys. Seven doesn't go in. I think 9 goes in. $11 doesn't go in. 12 does. $13 doesn't go in. $14 doesn't go in. And there is finally the pair that we needed, right? Again, don't feel like you're obligated to write all these down. You can if you want to. Again, there's no harm in doing so. And if you feel like I'm going to guess and check for a couple of tries before I start just going exhaustively, that's cool too. Just keep in mind that you don't want to spend too much time guess and checking, because not all of them are doable, and it's really difficult to tell it's not doable until you've done all of the possibilities. We'll eventually come up with a better method than that, but we're several lessons away from that. But anyways, so we got the two that we needed. Just as an aside, does it matter the order that we use these? Like, could I have done 32 and negative 15? Does that make a difference? Nah, you'll get the same answer either way, so it doesn't matter whether you put the negative 15 first or second. It'll be fine. You just have to make sure you do like the plus and negative thing so that there's a plus sign in between the two sets of parentheses. But as long as you do that, it doesn't matter which one goes where. From the first group, we can take out a 3x, right? And from the second group, we can take out 8. Good. And then what can come out? 4x minus 5. Very good. And what's left? 3x plus 8. Wonderful. So again, what we're seeing here is often the hardest or the most time-consuming piece of this is finding the two numbers, right? If you can find those two numbers, things usually go a little bit quicker from there, but that's the hardest part. There's no good, short, quick way to do that, finding those two numbers, other than just kind of using what you know about multiplication times table stuff to find them. I wish I had a better answer for you guys, but there's not a better way to do that. So for completing the square, we want to go from a standard form equation to a vertex form equation. So I'm just going to write out going to do some examples, and then along the side we'll kind of write out the steps that we're using as kind of some justification. Okay. So if I look at my vertex form, the key is going to be getting this piece. So what I'm going to do is I'm going to take this part and try to turn that into the x minus h squared part. Okay, that's going to be what I'm going to try to do. So the first thing I would want to make sure is the x minus h squared part, its leading coefficient is 1, because that's the coefficient on x, right? I would need to start by making sure the coefficient on my x squared is 1. Well, that's done for me already, right? Cool. The next thing that I want to do is I want to add and subtract a number so that I can do the factoring to get to this. So what does that mean? Well, if I went and FOILed this out, it would look like this, right? So what I need to do is figure out what this number should be based on what I have here. So in our problem, our 4 is basically the 2hx. Or I'm sorry, is the 2h. And we have to figure out what h squared is. So I have to take 4, and I have to divide it by 2. That turns it into h. And then square it. That'll give me h squared. So 4 divided by 2 is 2, and 2 squared is 4. Oops, let's write that in black. So have I really done anything at all? No, if I add 4 and then subtract 4, it's the same thing. I haven't done anything to change anything, right? It's just written a different way. Because all I've really done is added 0, which doesn't change. Everybody's okay with that? This piece now factors. And in fact, it's going to factor because it's exactly this. So it's always going to factor the same way. It's always going to factor to x plus b over 2 squared. And then I just have the stuff on the outside to combine. Just as a piece of vocab as an aside, this type of polynomial is called a perfect square polynomial. So literally the name completing the square comes from when we do this add 4 and subtract 4 part, we've literally made a perfect square polynomial, that piece in parentheses. That's what completing the square is. Like, that's where that name comes from, is because we've taken the last piece that we need to make a perfect square polynomial. Let's do another example. Okay, we'll do several here to get the feel for this. I'm going to make this one a little bit trickier, but not too bad. So let's say we have, oh, I don't want to do that. Let's make that 10. So my first step is I need that leading coefficient to be 1. Right now my leading coefficient is 2. So what should I do first? Well, I'll just factor off a 2. All right, we'll just make that leading coefficient 1. So far, so good. Next, what do I do? I'm going to add and subtract b divided by 2 squared. What's b in our case? Well, -6, right? But since we're squaring it, calling it 6 is fine. You'll end up with the same answer. So where should I put the plus 9 and the minus 9. Should it go inside the parenthesis or outside the parenthesis? Or one of each? Right, because before we didn't have a parenthesis already there. You guys know that? Notice that? Here we have a parenthesis already there. So where's the plus 9 and minus 9 going to go? Should it go inside the parenthesis or outside of it? It's going to go inside. Again, b was negative 6. Negative 6 divided by 2 is negative 3. And negative 3 squared is 9. So b divided by 2 squared is 9. So that's where the plus 9 and minus 9 came from. Now, this stuff is my perfect square, right? So I don't want that other, the minus 9 and the plus 5 inside my parenthesis. How do I kick those out? Can I just do this? No. Why can't I do that? What's the parenthesis around this whole thing saying? Why is the parenthesis got to be there right now? What was that? Multiply by? Right, it's getting multiplied by 2. Everybody agree with that? So in order for me to kick out those last two numbers, what do I have to do first before I kick them out? Multiply them by 2. So all I'm going to do is just distribute to those last two numbers. I'm going to leave everything else where it is. But after I've distributed the 2, out they go. Shove them out the back door. Is everybody okay with that idea? Now we can factor. So x squared minus 6x plus 9 is going to factor to x plus b divided by 2, which is negative 3 squared. And then negative 18 plus 10 is negative 8. And if you wanted to, you could really just write this as x minus 3 instead of plus a negative 3. Is that okay? Oh, excuse me. Let's do one more example. This one will be a mean one. Okay, what do I want to do first? Edmund? Good, I factor out the 2. So when I factor out a 2 from 5, what does it become? About just 5 over 2, right? And similarly, when I factor 2 out of the 7, it just becomes 7 over 2. Everybody cool there? Okay. Then what do I need to do? Good. So I add or subtract b divided by 2 squared. So in our case, b divided by 2 squared is equal to 5 over 2 divided by 2 squared, right? Dividing fractions is the same thing as multiplying by the reciprocal. And exponent of a fraction I do to the top and bottom. So really that's 25 over 16. Is everybody okay with that? I wrote out all that extra work because I know that sometimes we do stuff with fractions, and if we don't write it all out, it's not super obvious how we got our numbers. So I wanted to make sure I did that for you. Now there's no real reason you would have to do that, but I did it so that it was a little bit more clear. As to what I did there. Okay, so that's good. What do I do next? Very good. I'll distribute the 2 to the last 2 pieces. So that becomes negative 25 over 8 minus 7. Right, 2 times 25 over 16 becomes 50 over 16, which reduces to 25 over 8. And 2 times 7 over 2 becomes 14 over 2, which reduces down to 7. I didn't write that part out, I just said it aloud. I hope you're okay with that. Okay, so then we need to factor that trinomial there. How does it factor? It's always going to be x plus b over 2, which in our case is 5/4. Everybody good with that? So I just stole that from the work I already did. No need to do it again. And then I have to subtract negative 25 and negative 7, or add negative 25 and negative 7. To do that, I need to have a common denominator. The common denominator there would be 8. So 7 becomes negative 56 over 8. So when I combine 25, or negative 25 and negative 56, I get negative 81 over 8. And there's my final answer. What do you guys think? Okay. So at this point, we now have a complete map on how to do this, right? So what if we ask you to take something like 2 times x minus 3 times x plus 5 and write that in vertex form? What form is that currently in? That's intercept form, right? We want to get to vertex form, so we're going to have to FOIL it out to get into standard form, and then do completing the square to rewrite it in vertex form. Everybody okay with that plan? Okay. So if we FOIL this out, and then combine our like terms, oops, we get this, right? And now I could distribute the 2, but what's the first step? What's the first thing I would do to start doing the completing the square? Factor the 2 back off. So like, why multiply it through just to factor it back off at the very next step? Seems silly to me. So what should I do next then? Yeah, do the b over 2 squared. So our b is 2. 2 divided by 2 is 1. 1 squared is 1. Good. Then what? Yeah, kick the last 2 out the back. Distribute the 2 through to those guys. And I combine the like terms and multiplied all at the same time. I hope everybody's okay with that. Since there's no fractions or anything in there, it seems pretty decently okay to do, right? That's not terribly difficult arithmetic to combine all in one step. And then I would need to factor. And how is that going to factor? X plus b divided by 2, which is 1. And we're done. What if we have a problem like this where I ask you to write in intercept form? What form are we currently in? Vertex form. So to get to intercept form, we first have to expand to get to standard form, and then factor to get into intercept form. Everybody's okay with that plan? Okie dokie. So now we're in standard form, right? So to factor this, we need to find the 2 numbers that multiply to give us what number? 5. And add to give us 6. Those 2 numbers are not 2 and 3. Those add to give us 5 and multiply to give us 6. Oh, guys. What about 1 and 5? Who feels silly now? I gotcha. So we'll rewrite that then. Oops. And make our two groups. Take an x from the first group, a 5 from the second group. We have now an x plus 1 in common. When we factor that off, we're left with x plus 5. Bingo, bango, bongo. We're done zoned. Okay. One little catch here. I'll give a minute before, because I'm going to scroll back up to that little map that we wrote there just a moment ago. But looking up and I'm seeing people still writing things down, which is cool. So I'm just going to kind of shuffle here in place and talk without actually saying anything, just so it's not awkwardly silent. You know, sometimes that gives you the willies when it's just silent for no reason. So I'm going to continue talking without actually saying anything, just to kind of fill the background with some sound so it doesn't get too unbearably weird. Okay, I don't see many pencils moving anymore, so I think we're pretty much done. So if we go back and look at this route, foiling, we can always do, right? There's never an instance where foiling is a problem for us. Completing the square, we can always do that. There's never an instance where that would be a problem. Expanding, we can always do that. There's never an instance where expanding can be a problem. But factoring, using the methods that we have, not always possible, right? Now eventually we're going to kind of fill that and make it so it's possible, but it's not going to be easy to fill that last little void, and that's going to be one of the last things we deal with in this chapter. But I just want to put that out there for you guys. Okay, so that's the last idea that I want to pose here. So just kind of keep an eye out for that. Again, we've mentioned this several times, that not every quadratic we've seen is going to be factorable using the methods that we've presented so far. Now, depending on how you're defining factoring, everything is factorable. And we'll eventually get to the point where I can show you kind of how we would do that in practice. But that's a little ways off still. So for the rest of our time today in class, I've put 2 assignments in the content library on, one which is a factoring practice sheet. So the first 10 problems, I've just given you coefficients A, B, and C and asked you to find the 2 numbers that multiply to give A, C, and add to give you B. You're not going to actually do any factoring there, just practice finding those 2 numbers. Okay with that? And then the second 10 problems are actual quadratic polynomials that I'm asking you to solve. Again, I recognize that some of us know the shortcuts to do these things quickly. I'm asking you not to do that yet until we do the shortcuts in class. That'll be what we do in the next lesson, is talk about the factoring shortcuts. But I do need you to be able to do this process the long way that we've described in class, because not everything is going to be able to be factored with the shortcuts. So I need you to practice the long way here. It won't be too much longer before I start letting you use the shortcuts where they're available, but not quite yet. And then also I have homework 4 posted. Here I have 3 completing the square problems, and then several of these where I want you to transform them into a different form. So you're just using that map. Sometimes you have to do factoring, sometimes completing the square, sometimes foiling or expanding, or a combination of several of them. But that's it. Everybody cool? Okay. Why don't we take the next, whatever we have left in class, 20, 25, 30 minutes, something in that neck of the woods, and get started on that. Of course you can. You're welcome. Yes.